This is the awesome game I made in AppLab. I'm pretty excited about it. I'm going to show it off and then I'm going to show you how to make your own. I'll share the code as well. So let's hit run Crossy Code, because it's like Crossy Road or like Frogger. You can play it on your phone, right? Because I have these touch controls, or with the arrow keys and the shift key. Let's see. Basic Frogger movement here, or Crossy Road. They're really slow at first, the enemies, but of course they speed up with each level. Notice how this is a 2 now? That's because we're on level 2. I think it's fancy. And and I lost a life up here. I only get 3. These obstacles, obviously, you can't hit. They spawn randomly, so they're making things a bit more interesting for us. And slowly the enemies build up to be quite the problem. Oh well. But there's the game, right? Game over. If I play again and get one of these higher scores, it will save and it will say high score and have a trophy and stuff. And each time you hit play, it's gonna spawn these obstacles a bit different. The speed's gonna slightly vary. And then what else varies is where the bonus hearts or the bonus rockets show up, so you can get an extra boost or life. Let's now talk about, the code that's building this. It's gonna look complicated. It isn't. It is kind of, but you're gonna be able to do it. I want to show this off so you can add to it, build on it, make your own. Definitely could be used in an AP performance task or something of that nature. So, right off the bat, what I do here is declare the variables. So, move count, that's just how big the step. Nope, that's just the counter for the score. So my score is actually a move count. Every time you go forward, you're getting a point. This looks like chaos, but that's because we set it all up below. Lives is going to be set to 3. This is the size of the player movement. Key up is just to make sure someone can't hold down an arrow key and go forever. I want them to hit it each time. The boost, which is how much to add to the step, you'll see that below. This keeps track of our high scores, right? So variables. Then we set the positions for these buttons, here, 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 here. We set them to be hidden off the screen negative, and if someone clicks or taps, they show up. And then that's my random tip at the beginning. Now, on the event of start button, right? And you're aware of these if you've done AppLab, but what this is doing is saying, hey, computer, on event, so, wrong one, on the event that the start button is clicked, which is this button, notice the ID there, what will happen? Well, this function will execute where we switch to game screen and I start setting up all the enemies in our program. And so that's also then what we're going to be using for movement. This is our key down. That is what's used to control. That's what's used to make sure that the player doesn't just hold a key down. And yes. And so first we say, okay, is the keyboard key down? If so, have they lifted it up? And then we're going to check to see, we're going to call the function player movement event.key. And then we also call player movement when all the on-screen buttons are pressed, and we pass these parameters, up, left, right, shift. Now for player movement, right, so the parameter is going to be the key that was pressed, or event.key. Event.key, on the event that the game screen, that you're on the game screen and I press a keyboard key, right, you press a keyboard key down, we use this parameter event. It's a default one. It's one that the code.org allows us, it provides to us. What event contains is anything like the mouse position when you click, or the key that was actually down when this was triggered. And that's why down here, when I call my player movement function, event.key is passing the key that was pressed, a string representing it, like the word up or down. It's passing that to player movement. So down here in player movement, now player movement knows, oh, up. This is equal to up. So what I do right off the bat here is I get the player's current X and Y position. I then say if key is equal to up, so if the parameter is up, whatever we pass when we hit the key, well then we're going to what? We're going to take the player's y value and minus, because remember 0y is at the top of the screen and 400y is at the bottom, 450. So you subtract to move up the screen. So we're going to take the player's y value, we're going to subtract however much my step size variable was, and that's 20, right? That's how big I wanted a step to be. And then we're going to subtract the boost. So if they have a boost, if they used the shift key or clicked on boost, for the current level, that adds some amount to their step. I think it doubles it right now. And that's set below. That's going to be what happens in a similar fashion for up, down, left, right to some degree. We also use obstacle collision, and this checks well, if the player actually hits something, and we'll get to that later on. Player Y value is less than... now this is a line. This if statement here is checking that if our Y value is less than 410, somehow I'm way down at the bottom. Oh, if our Y value is less than 0, somehow I'm up here, right? Because 0... y is here. And so if I'm above the top of the screen, what we're going to do is we stop the timed loop, and we'll see the timed loop in a second. It's what controls enemies. So we stop that. We then, first we set property to 410. So we first spawn our player here. We then stop the time loop. We add 1 to the level count, which is displayed on the side of the truck. We set boost back equal to 0 because we're now at a new level. So if they had a boost, we want to get rid of that. And we want it equal to 0 because each time we add whatever boost is equal to for every step. So we set boost equal to 0. And then we set the label level count, and that's this. And then we say move enemy, cart, truck, and these are our 3 enemies. So we stopped the time loop, and then we moved them again. When we say move enemy, well, we'll get into that. Now these all have similar functionality to up, it's just down, left, right. If the player's, so if somehow the player gets below the bottom, we just position the player back to 410 if they're trying to go off the screen. And then this is the shift key, and this is where we set our boost. Oh, here's our boost. Apparently it's equal to 10 right now. But we can certainly increase that. Maybe I want it at 20. Okay? And then here's where I control hide element boost equals 3 minus boost count. And that's because the IDs for my boost are boost 1, boost 2, boost 3. So boost plus 3 minus boost count. However many boosts we have left, we're going to hide the one we just used. All right. This is my key up function. That just, again, it's so you can't hold a key down and keep going. This is checking for bonuses. This is a bonus item. So when it appears, we run check for bonus right down here at the bottom of our player move function. And that's because we're looking to see if the check collision, bonus item 5535, and we'll get to this collision function. But what we're seeing is if the player is on these bonuses, what we do is add 1 back, 1 boost back, or add 1 life back to the appropriate area and make that disappear. Now, move enemies. This is like the meat and potatoes of the program. So a bunch of new variables here. And so just to start us off, I use parameters for the enemies because I was thinking of expanding. It gives me versatility to change them at a later date, and it just creates a cleaner program. So ID1X is whatever enemy I pass first as this parameter. And if you saw up here, the enemy was the cart. Yep, cart, truck, and then motorcycle enemy. And we want that because the truck is specific because it's coming from the left. So now what I do is I set their x's to 1, 2, 31, which makes sense because 1, 2, 30 is the truck, 1. Okay, so that's what we do at first. That's what I set their x equal to. And this is just this variable. Okay, we haven't actually set the animations X. This is the variable ID1X, ID2X, all right? Now, for their Y value, I wanted them to change a bit each level, but I keep control of them still, because I didn't want them completely overlapping one another. So I gave them a little bit of a random variable so they could move up and down accordingly. Now I set the properties. Oh, no, then I run my get colors function. We'll see it below. It just returns a bunch of colors, honestly. And so we're going to use that. It returns an array of colors. We use that to to assign all of our items colors. It's so everything will have a different color too, and that it's dark enough to see. So set property, we set the colors of all of them. We then get obstacles. This sets the colors and gets the obstacles and sets up the obstacles for our game area. Get bonus items. This checks to see if we will have a bonus item that time, and we'll get to that as well. Speed increase, and here is what makes the levels more difficult as you go. Slowly, the cars get faster and faster, and I can always just change this. I put it up 0.1. And so speed increase equals speed increase plus level count times random number 0 to 3 times 0.3. So slowly, and this sometimes you'll gain a lot of speed, sometimes you won't gain anything because it's 0 to 3. Slowly, it gets more and more difficult. So, and keep in mind, we keep adding to speed increase. So this is whatever speed increase used to equal plus this, right? So it's always slowly going up. Now, a timed loop. What is happening with our timed loop? This means every 10 milliseconds. So it's constant, right? And this is going to run, well, based on those 10 milliseconds. It's going to run quickly and constantly until we ask the computer to stop it. So right at the top, we're adding 1 to each of the... We're adding 1, yeah. So we're always going to add or decrease 1 to each of our enemies, right? So they're always going to be going up each time we run the timed loop, which means every level they will increase by 1, and then they will also have this speed increase variable that is going to impact how quickly they go. Then we set all of their positions to the stuff we had up here, which was the edges of the screens and those random numbers. And then this level label is this, right? So what I'm having it do here with these weird numbers is follow ID2X, which is our truck, ID2, and then I have plus 47, plus 15 to get it to where it's on the side. Okay, and now these are just checking if the different enemies are off the screen, and if so, they respawn. Then I have this long check for collision with OR. Line means OR. So I'm checking if each of these have collided with our enemy. And if they, with our hero, with our bug, if they have, we run enemy collision, which you'll see below. Now, get obstacles. What this is going to do is we have our 3 obstacles. I set them all to off the screen. Negative 250, 250. You won't be able to see those. I also want to point out variable obstacle number equals 1 to 3. This decides how many obstacles we will have. So, if obstacle equals 1, we are going to have 1 obstacle. If obstacle number is equal to 2 that time, we have, well, 2 obstacles. And if it is equal to 3, we have 3 obstacles. And they're going to randomly spawn between 60, right? So obstacle image is going to spawn between negative 10x, so it could be off the screen, and 220, but just a little bit, it would still show. And 220, and then random number 60 to 340, so anywhere in this area. And so those will show up again at random spots. Sometimes they're on top of each other, and that is fine. Get bonus. Now I made bonuses more rare. You can only get a bonus. Well, here, set position, bonus heart, -400, negative. So both of our bonus items are totally off the screen. We then have this variable bonus number 1 to 6. So I made it so bonuses only show a third of the time. And then now I also made it that they only show, so if the random number is 1, bonus number 1, what would usually show is a heart. But you also have to need it. So if they already have 3 lives and the random number's 1, they're just out of luck. This ends and there's no bonus items that time. It does not go and give them the other bonus item. And if the random number happens to be 4, well, as long as they've used one of their boosts, the boost would show. Get colors I talked about earlier. What I'm doing here is I get 3 numbers, right? Random numbers. And then I have these variables that are going to be Boolean values that I'm asking, hey computer, is color 1 less than 60 and color 2 less than 60 and color 3 less than 60? And it's going to be light is either going to be true or false. Because if they're that light, I'm going to change them. Or similar, if the colors are too similar, is the absolute value of color 1 minus color 2 plus the absolute value of color 1 minus color 2 less than 60? Meaning it's all practically the same number. And that's just going to be true or false. If it's all less than 60, that would be true. And then I check for a range of pastels. If and these are all or, so if light was true, if similar was true, or if pastel was true, I'm going to reassign the colors and I pick more specific ranges. Variable colors equal, right? So this is individual variables, color 1, color 2, color 3. This is an array of colors. And then what I'm doing here, this looks terrifying, I'm just building strings. So I'm taking the colors and building strings, but I'm putting them in different spots. So the first one will have color 1 first, then color 2, then color 3. The second is going to have color 2, 3, 1, and all of these are different all the way down. So I'm sure that none of them have the same color because I know they'll have different numbers unless the numbers happen to be the same. Well, wait a minute. They can't be because of that. All right. So I then append all these to the array and I return them. And that's what, when I'm assigning colors or establishing what color something is, where, like here, there we are, okay. I passed them as parameters, so that was a bad example. But like here, colors 2, that's the third index in an array, right? Because colors 0 is the first index, because arrays start at 0 and count up. All right, that's my colors. And check collision. This is a very important one. So how I am detecting if my images collide. So what I'm doing here is I just said enemy X area, Y area. Now, if Y area is greater than the absolute value of get Y center player. So first I get the center of the player, right? And how am I getting the center? Because remember, images give you the top corner. Well, let's look at this get Y center, or X center, but Y center is our first one. Y is equal to get position image, an image I pass as a parameter, so the first time it will be player. Now I want the height of that. Get the property image height. Now I take Y and I add the height over 2 to Y. And that's going to be the Y center, and I return Y center. And then, so what we're doing after that, it's going to get returned up here, and it might seem a little bit counterintuitive to add to the height, right? To add Y, because Y is 0 at the top and 450 at the bottom. And it's something I did earlier on as a mistake, but honestly, I left it in part because I want a bit of that buffer zone around the vehicles anyways, and well, it works great. I figured it out to get the numbers. Good for me. So, and I'm doing absolute value too, because I don't care if it's positive and negative. I don't care if the player is above a little bit or below a little bit an item. I want to know that they are in contact or that they are close to being in contact. And what is Y area? Y area is the parameter that we pass, and what that's going to be is how close in the Y direction can these items be. So for one, I left it at 35 or 40, and that means they can be within 40 pixels of each other, and then at that point we're going to say that that's contact. And so then I make sure that if they are within, their Y values are within 40 of each other, well, are their X values. And so we get the center X, get the center of enemy, we get the center of the X value for the player and of the enemy. And then if that is also true, right? So if that is less, the absolute value of those is less than our area, less than the area I say they can be within, then we're in contact. And so this will return true, otherwise it will return false. Now, if it returns true, where is it called? It's going to be called right here, right? If this returns true up here, enemy collision. What does enemy collision do? Well, that's what we were going to get to. We just hit those next. So first off, if we hit an enemy, we're going to take one away from our life. We're going to stop that time loop that is having them go back and forth, back and forth. We're going to stop that. Now we're going to check to make sure if our lives is less than 1, right? So if our lives are 0, game over. And that's what happens. If lives are 0, we hide. Oh, these are the screens on our game over. These are the elements on game over screen. Hide smile. Set the screen to game over. I meant hide win image, which is our trophy. Show smile. It's fun that I call it a smile because it's a frown. And then if this is the first round they've played, right, scores only stay for the immediate rounds that you're playing. Once we hit reset, we don't retain them. So if this is their first round, this will autofill with all their scores. And then we do our for loop, and we're checking, because if it's not their first round, we want to check each score and see where they would fit and add it accordingly. And then, let's see what we got. Set score number over, move count. Set text level number over, count. So when we load our game over screen, we're setting the score and the level so they know. We're now else. So else means if their score, if they did not have less than 1 life, so that means they still had some lives left, we set the position of the player back to the starting point. We hide one of the 3 heart elements, and we get that heart element by, remember, we took 1 away from lives. So we say, okay, 3 minus lives. So if they only have 2 lives now, we got to get rid of life element 1 or heart 1. So I say heart, and I concatenate it with 3 minus lives. And so if we only have 2 lives, that would be a 1. Heart 1 would be hidden. And then we start the move cart enemy and truck again. This is checking for obstacle collision. We loop through the different obstacles. And this, finally, is the retry button on the game over screen. So, that was way too fast, but I wanted to show it off. I wanted to go through it a bit. I'm going to post a link to this below. You should definitely try it out, play it, make something better with it. Use these ideas in your AP performance task. All of that good stuff. And, have fun while doing some code. I've been playing this way too much. No shame. Wah. Boo. Oh, yikes. And if you build something cool or remix this into something cool, you should absolutely post it. You should absolutely post it below. I'd love to play all the stuff y'all make. Okay, one more round.